the session for people who aren't able to join us so that they're able to see just some of the work in minitab. But let me change what screen I'm sharing with you guys so that I'm in minitab. Okay, is everybody seeing minitab now? Yes, nod heads, thank you, Derek. All right, it's so funny when I go to this view that I've got like 4 or 5 people on the right-hand side of my screen, and most of you guys are in black squares, so even if you're nodding, unless you have your video on, I can't see you nodding. So please feel free to type in the chat box or just unmute yourself if you need to, and to say something, because I do want to be able to answer questions. I don't have like a set thing that I'm working through right now. I'm going to be showing you different features that are specific to what we will be doing in class and how that can help you complete the case studies and everything moving forward. Because from this point on, I don't really expect you to do anything by hand. And it's because you wouldn't ever do these by hand. So even though the textbook has the fully worked out equations and the homework problems, I'm not going to be doing homework from Wiley Plus or the textbook anymore, because I want you to be using minitab to do the homework problems. So you would never do a linear regression by hand in the real world. There's no reason to do that. You would never do a two-sided t-test and by hand. That it doesn't happen. You would only ever use some sort of software package. So it might be minitab, it might be SPSS, it might be SAS, you might use Excel for different things, but you wouldn't be doing it by hand. So I will no longer be having you, oh, okay, thanks, Mary. I will no longer be having you guys do any homework equations by hand. So this case study 2, case study 3 will be on linear regression, which is next week's content. And then our last week of content, and I'm going to ask for feedback on this. The last week of content that we're supposed to have is chapter 13, which is doing ANOVAs. And it's kind of high end for an undergraduate course. You don't really do ANOVAs at an undergraduate level. Dr. Hill has included it some semesters, and in other semesters he's not included it. So it's been kind of a back and forth thing. Last semester, you may or may not know, was my first semester here at USI. So this is only my second semester at USI, and and we're in this really weird online teaching format for most of this semester. But I've taught for a long time at Purdue and everything, but it's only the second time I've taught the course at USI. And at Purdue, I never taught this course going all the way through ANOVA. So we could use that week as just prep for exam 3, practice with minitab, review of all of the stuff for a one-sided test, a two-sided test, a linear regression, cover a few more functions in minitab before we do exam 3, which again is non-cumulative, and it won't be using Proctorio or anything. It'll be just an exam that opens and you have a week to do. If you guys really want to learn ANOVA, then we'll do ANOVA. But I'm going to actually send that out. I might send it out like as a Google survey, Google form that I just email the class, and you can just click. I'll ask, do you want to cover chapter 13? Or do you want that week for an additional week to focus on minitab and prepare for exam 3? And people can vote yes, no, or I don't care. And then whichever wins, that's what we'll do. So that's kind of my thought for the content. It says that we'll do it on the syllabus, but it is kind of optional. So with that in mind, when we look at minitab, the first thing, yours might look a little different. Version 18, this is actually white space usually instead of this gray with the minitab logo going across the top. But the bottom, having the cells going across the bottom, should look normal. And so whether it's from Word or Excel, you should be able to just copy and paste directly into these cells. When you copy and paste, you want your headers to be in the gray box, and then the numbers to actually start in the first box 1. So I'm going to copy some data really quickly from Excel that I have open and paste it in here. Okay, so I am pasting those cells, and so this one, there was actually a gap, so I'm going to, should delete that gap before I moved it. Cut and paste all of those work the same. Okay, so I have an n equal to 25, and I have a title in column 1. These are really helpful because when you have, like for the case study file, you have multiple columns of data going across that I've said, you know, look at the data from column 1 and column 2 or something like that. That's what I'm referring to. C1, C2, C3, C4. Those are the columns that you'd be pulling the data from. These headers in the gray box are helpful because when you actually use minitab to then do some sort of test, you're able to select that column. So the first thing I could do is when I look at the options, I have all of my toolbars going across, and really we stick to basic statistics pretty much all the time. That in this class, that is really the only one that we'll use, except for doing a regression, which is the tab below it. If you guys decide that you want to do ANOVA, we may go into that tab as well, but we'll start on the stat tab. The graph tab is what we used when we were doing chapter 6, but some of these plots you can actually select to have those plots displayed while doing the statistics testing as well. So basic statistics takes us all the way through chapter 10. As far as what we would be covering in the course. Chapter 11 is the regression tab. Chapter 13 is the ANOVA tab. So we also, within those chapters, we don't cover it in this course. It's a graduate level material, but the non-parametric tests, so the Mann-Whitney, the Kurzweil-Wallace, these are the tests that you use when you have data that you can't assume to be normal. So remember we had adjustments for the Poisson and for the binomial and said, well, as long as the sample size is big enough, we're going to go ahead and treat those as normal. Sometimes the data is just not normal. It just isn't. And you can't pretend that it is. You can't approximate it. The normal rules don't apply, and so you can't use those types of tests. And that's what these other statistical measures for the non-parametrics are used for. This is used when your data comes back as being non-normal. So when you're actually in the field, the first thing you have to do is you have to test for normality. And that's where you do that normal probability plot that we did in chapter 6, where you were actually able to see, do the dots fall within the lines? And once we would see whether or not the data was normal, then you would know whether or not it was appropriate to use all of our statistical tools that are based on normal data. Because this book focuses so much on the tools used with normal distributions, they give us normal data, except for the chapters that they're specifically looking at having you do normal probability plots. So for the most part, we're always going to have normal data in this class, but that's not true in reality. So that's just something, again, if you continue on to graduate school, you will see a lot of that done. So basic statistics. First thing is I could just click display descriptive statistics. This is one of the things that you just need to get used to doing, is in this box that's on the left hand side, that's where you select the column. So you have to click on it first, what you want, and hit select, and that is when it'll pop into a box to actually do something with it. And so you may remember this, we did this just a little bit after chapter 6 for all the different options that you could do. Display descriptive statistics, hit OK, hit OK, and we get this nice little bar going across. So we get the n, we get the mean, the standard error of the mean, the standard deviation, and we're getting the min and the max, which we could use to calculate the range. We're getting the quartiles. So for all of your problems, if you're starting with a data set and you need to just know what the data is, generally speaking, like understand what the data is looking like, you'll do those descriptive statistics. So if there was a problem in the case study that just starts out saying like, record the meaningful descriptive statistics. What we're talking about is the mean, the standard deviation, the standard error of the mean, and n. Those are the most important things for any of the tests that we're going to be doing. So just this first part, this we had checked off because I think we were doing like box plots and things like that, and we were still talking about those. So that's displaying descriptive statistics and could be useful both on exam 3 and on the case studies. But for actually doing the test, I'm just going to look at the data that we have in column 1 and say, what if I compared this data against a hypothesis that the mean was equal to 98? So this sample mean is 98.264. I'm going to compare that sample mean against a hypothesized mean of 98. And I'm going to use a 95% confidence interval. So this would be in the form of a question. It would be, you have a normal distribution that has been provided, and you are going to do a one-sided test. So here, I could do a one sample Z, and when you click on this, one or more samples in each column, or summarize data. So if you have data that's given to you in the homework, and it already gives you the mean, the standard deviation, the n, and all of that, instead of raw data, you can click summarize data, and you can just put in sample size, sample mean, known standard deviation, click perform the hypothesis test, put in what the hypothesized mean is from the question itself, and then on the options is where you set your confidence level and your alternative hypothesis. And so you'll see that you have the confidence level here can be just edited. So most of the time, for most of our problems, we work with a 95% confidence interval because from an industry standard, we think that that's good enough. If it's a really tight quality issue, you might do 99 instead, and then you just type 99. So remember that this is a percent. So if your alpha is 0.05, your confidence level is 95 because this confidence level box is a percent. So, you need to type it in not as 0.95, you need to type it in as 95.0. So just remember that if you're having to change the confidence level back and forth between 90, 95, 99, whatever the problem may be giving you, make sure you type it in as the percent, so 95.0, not 0.95. Then this is the same place that you would select if you were doing a one-sided test or a two-sided test. So a two-sided test means our null hypothesis is that the hypothesized mean equals, and our alternative hypothesis is that the mean is less than or greater than. In this case, we're just going to do a two-sided test, so we're going to leave it as the mean equals, and the alternative hypothesis is the mean does not equal. But like on your exam, you had both one-sided and two-sided tests. I think in the case study, you have both one-sided and two-sided tests. Certainly by the time we get to exam 3, you'll have both. So this is the box where you need to check that off. So because I only have an n of a 25 and I don't have an actual population standard deviation, I'm going to go ahead and actually I'm going to make up a standard deviation. But if this was a problem given to you, you would need to use a t-test, right? Does everybody understand why I need to use a t-test? So I have a sample size of 25 and I don't know the standard deviation. For the sake of running the test, I'm going to make it up based on the sample standard deviation. just so that I can show running the one sample Z. I'll do it again as a one sample T. But one of the things that's going to be part of case study 3 and part of exam 3 is that I'm not going to tell you which test to run. The first part of every, and I think there's a few like this in case study 2 already, that part A is what test do you run and why. And so when that question is answered, if this was the data you were given, you would say, I will run a one sample T test because there is no known standard deviation and the N is less than 40. That would be the answer. I'm going to say it one more time because it's really important that you guys understand. If I was to run this, you would say, I'm going to do a one sample T test because there is no known standard deviation and N is less than 40. So when in doubt, if you ever have doubt when you're looking at the exam or a case study, perform a two-sided hypothesis test, okay? And the reason you would perform a two-sided hypothesis test is because the two-sided hypothesis test is always going to be more conservative than the one-sided. Remember we talked about that before we broke for spring break, that the one-sided hypothesis test gave us a bigger range. So if you only cared about, like, I want a fill rate and I want to guarantee it's more than something, but I don't really care if it's less, you know, that you only cared about one part of the measure, if that's true, the one-sided test gives you a wider range and more freedom from a production standpoint and from a sampling standpoint. Your test becomes more powerful without changing anything. So when you remember like sample size calculations and things like that, for a one-sided test, your sample size can actually be smaller. So it's helpful in a regular setting to use a one-sided test if you know that that's what you can do. But if you ever are feeling like this problem did not give me enough information, always, always, always choose two-sided because it'll be more conservative. And so that's the safe bet. And so if I was working in the field and I wasn't really sure, can I just look at one end or do I need to be looking at both ends? I would always default to a two-sided test because it will be a more conservative answer, which means my customer and my producer will have better results. The quality will increase. The other thing is, when in doubt, perform a t-test, because you almost never know, in reality, you almost never know your population standard deviation. Almost never. So because of that, we're almost always going to do a t-test in reality. And that is why if you look at your options here for stat, there is no two sample Z. It just doesn't even exist. We'll look through the two different kinds of t-tests, and well, the three different kinds, the two different types of standard t-test and then the paired t-test. So we'll look through all of those today, but you'll see that we only have the one sample Z because the population standard deviation has to be known. And we can't use this unless that is given to you. So if you have a question and the population standard deviation, sigma, is given to you, it's a z-test. If the population standard deviation is not given to you, it's a t-test. Now, even though we said in class, if it's more than 40, you can go ahead and use the z, now that we're using minitab and not doing things by hand, do the t-test. So unless the population sigma is given to you, use a t-test. And so for all the questions moving forward, those are the things that you're going to be looking at. Do you have a known population? And that would be using a z-test. Otherwise, you're going to use a t-test. And when in doubt, test a two-sided hypothesis. only use a one-sided hypothesis if it specifically says to use a one-sided hypothesis. Otherwise, assume that it's 2. So those are just some rules of thumb. Now, for the sake of showing what the results look like on a z-test, I'm going to make up a standard deviation that's pretty close to the sample standard deviation, and we're going to test it off a hypothesized mean of 98. So I'm going to do a 95% confidence interval just so that we can use this test. And one or more samples in the column. It's not summarized data, so I'm going to hit that. And by clicking into this box here, the box on the left-hand side populates so I can select the column that I want. And I'm going to put my known standard deviation. Let's see, the sample standard deviation was 0.48. It has a sample size of 25. So I'm going to say that the known standard deviation of the entire population would probably be a little bit larger of that. So I'm going to say 0.52. And then I'm going to perform a hypothesis test against a hypothesized mean of 98.0. And we'll go ahead and use that 95% confidence interval and the two-sided test. I always like to click on options before I run the test, even if nothing's changed, just to verify that it's the right thing, so that I always know that that's there. I hit OK, and boom, this pops up. So gives me my n, my mean, my standard deviation, my standard error. Same thing that we had seen in the descriptive statistics, right? So that's why I said those are the critical areas of the descriptive statistics. It go ahead and builds my confidence interval on the mean. So on the case study, like case study 2, it says record the 95% CI. This is the box you're looking for. And it has the lower end and the higher end, just a comma between the two of them. You can write it exactly like that. So when you're filling out the minitab worksheet for case study 2 or 3 or exam 3, you can always just copy and paste these boxes by clicking down and copying it and pasting it directly into Word. Copying it as a picture sometimes helps if you're going to convert it to a PDF so that it doesn't get distorted. So sometimes I recommend copying it as a picture if you're then going to save your document as a PDF. But you can just also copy that and put it into Word. So feel free to either write this by hand into the table given to you for the case study, or copy and paste the box and just put it right into your Word document. Here's the part that actually matters, right? So once again, we have our null hypothesis and our alternative hypothesis. There's a place on your case study to write those things down. This is what you should write down. Your HO and then the colon, mu equals 98, H1 colon, mu does not equal 98. That's exactly what you're going to write. It then gives you a Z value and a P value. And so our Z value is what we would use on the chart to look up that Z value, and we could calculate our P value from that, right? Using the Z statistic. This is a two-sided test, so it would be 2 times 1 minus the Z statistic for 2.54, right? So if I looked up 2.54, which I have a table right in front of me, 2.54, I get 0.9945. And so I'm going to do it real quick. 1 minus 0.9945 equals times 2 equals, and I get the exact same p-value answer on my calculator here, 0.011. Okay, this is where we have to know what we're talking about. We're looking to confirm or disprove our null hypothesis that this sample is representative of the population, okay? So what we're looking to say is this null hypothesis true, that the mean is 98? Well, what does my p-value say? My p-value says 0.011. My confidence level was 95%, so that means my alpha is 0.05. Is my p greater than or less than alpha? Someone unmute yourself and say it. Is it greater than or less than?
Less than.
Yes, my p-value is less than 0.05. If my p-value is less than 0.05, what does that mean? Do I accept or reject the null hypothesis?
Reject.
Reject. That is true for my z-test, my t-test, 1 sample, 2 samples. That is my measurement, my p-value compared to my alpha. So write this down. If you don't have this like glued in your memory already, write this down. When p is less than alpha, reject the null hypothesis. When p is greater than alpha, accept the null hypothesis. Now, it's important to not put in your mind that accepting is good and rejecting is bad. Okay, so like one of the things in your case studies is a weight loss program, and the null hypothesis for the paired t-test before and after, the null hypothesis is that there is no change, that the before results equal the after results. Well, if I'm doing a weight loss program, do I want my weight at the end of the weight loss program to equal my weight at the beginning of the weight loss program? No, I would want to reject my null hypothesis. If I reject my null hypothesis, that means a change occurred. That's a good thing, right? If I am doing a pre-test and a post-test in a class and I'm seeing I'm going to give everybody a test on Alexander Hamilton, and then we're going to go see the musical Hamilton, and then I'm going to give a post test and see, did anybody learn more about Alexander Hamilton after watching the musical? Do I want the results to be the same before and after? No, I want them to go up. I want them to be different. So in that case, I want to reject the null hypothesis. So don't have it in your head that rejection is bad. You've got to look at the problem and see what the problem is asking, because for your case study and for exam 3, for both the case studies and for exam 3, the heaviest weight of the entire question, the question's usually given in like 4 parts. The first part is, what test do you use and why? The next part is, fill in the table with your N, your mean, your standard deviation, standard error, 95% confidence interval. The next part is, write your null and alternative hypothesis. Give the p-value. So maybe it's 5 parts. The final part says, what does it mean? And you can't just write accept or reject. You have to actually give me a full sentence that says, why do I care? So we would say we reject the hypothesis because the p-value is less than alpha. But then the problem would have given you some words to say why this mattered, why this hypothesis test was being done. To say, you know, well, it's important to know whether or not the mean is at 98 because that's what the manufacturers need to fulfill their customer orders. So this is the customer requirement. So we're hypothesizing that the mean is 98 because that's the customer specification. So my null hypothesis is that the mean is 98, and that would meet my quality specifications at a 95% confidence interval. So 95% of the time, I'm pretty sure, based on this sample, that the actual mean of all of the product I'm running, from these 25 samples I took off the line, that all of my product would meet that standard that the mean is 98. This test, based on this sample, says, nope, that's not true. And so that's where that final part of the question is the most heavily weighted on the case studies and on the exam. It's, what does this mean? Because that's what's translating back into real words what all of this testing actually meant from a big picture standpoint. Does that make sense? So what I'm going to do now is I'm going to redo this test, but now I'm going to do it as a t-test, because a t-test is what actually makes sense since I don't have a known standard deviation. So I'm going to go ahead and select column 1. I'm going to perform a hypothesis test on a mean of 98, but now I don't have anything to fill in as a known standard deviation, because a t-test, you don't know the standard deviation. I'm going to click on options again real quick, just make sure I'm at my 95% and that my alternative hypothesis shows a two-sided test. I hit OK. And what do we get? Well, we get basically the same thing, right? So we have our confidence intervals set up there. We have these descriptive statistics should not change. Your confidence interval will, because it's a factor of your t statistic, not your z statistic, and you see that t value is different than what that z value was, right? Because the t-test is not the same as a z-test. So our t-test was what, 2.54? And now the z-test was 2.54, my t-test is 2.74. So you see there's a little difference there in my t-value, but what am I looking at? I'm looking at my p-value. My p-value is the same. So as a t-test as well, I still have a p-value less than alpha, I still reject. All right, so let's do some two-sided tests. These are all going to be t-tests again because that's all that we're going to do. And we're going to look at data. Goodness. Give me 1 second to download the chapter 10 data real quick from my file here. Sorry, we'll download chapter 10 data. Okay. So this data that I'm downloading here, I don't think is actually in your homework or your case study. Maybe it is. If it is, then you get a little gift. Okay, Club 1 and Club 2, I'm going to look to see that they are the same. I'm going to do a t-test on the means of these two as a comparison, and let's just, for an example, we're going to say that Club 1 is put out by, I don't know, golf. I know like Titleist makes golf balls. Nike makes golf clubs, right? Does Nike make, anybody golf out there?
Nike no longer makes golf clubs.
Nike no longer makes golf clubs. Was that a Tiger Woods thing? Didn't Nike sponsor Tiger Woods?
Yeah, they did for a while. They still make apparel and shoes.
Okay. So Company A makes Club 1. Company B makes Club 2. A consumer is considering buying Club 2 because Club 2 is cheaper. And so you're looking at reviews on Amazon and you see, you know, here's this one that's name brand and it's really good and really well reviewed. This other one is like $250 cheaper and it's also really well reviewed. But you actually get some data on their driving and, you know, what sort of drive you have. Oh gosh, I need to pick examples for stuff I know about, not things I don't know about. Derek's laughing at me, everybody. You can't see his face, but I can, and he's laughing at me. All right, so two sample t-test. You get the choices. Both samples are in one column. Each sample is in its own column and summarized data. The both samples in one column, I think you see in your case study for the hospital data that when both samples are in one column, you see this sample ID box. And so for that part of your case study, the samples I think are in column 2, the sample IDs are in column 1. And so all of the samples from hospital A are labeled A, and then directly below it, then you have a whole bunch of data for type B. And so the sample IDs were in column 1 and the sample data is in column 2. This is how you would do that. You would click on both samples are in one column and you see that you would select which column has the actual data and which column has the ID. And I think that that's the hospital question on your case study. The next option is each sample is in its own column. Again, That's what we actually have. We'll have Club 1 and Club 2 in 2 different ones. The third option is summarize data, and you're able to just type this in. And I think one of the questions on your homework is like this, where you are just going to literally type the answers in. Actually, I think you have a couple homework questions like this, where you're going to type in sample size, sample mean, standard deviation of sample 1, sample size, sample mean, sample standard deviation of sample 2, and run the test at the selected confidence interval. But for the sake of playing with Minitab, we're going to do the actual one here. So sample 1 is Club 1. I hit select. That moves it into the correct place. Sample 2 is Club 2. Options. Here's the big thing, and I tried to explain this on the lecture video. Here's the big thing. Okay, our hypothesized difference is always that the hypothesized difference is 0, right? So that means sample 1 equals sample 2, that they are the same. Confidence level is just like we saw for the one sample test. Alternative hypothesis, we have one-sided tests for greater than or less than. We have two-sided tests as our default. And like I said, if the question doesn't say it, assume it's two-sided. You could change this hypothesized difference. You could say, there could be a question that says that the difference between the means is at least 5. That's where you would put that number 5. You would not run it by the default saying that the hypothesized difference is 0. You would change that to be 5 and say the hypothesized difference is whatever number has been given to you. In this case, 0 works, but that's going to be the default for Minitab every time you open this. So if the problem says that, the manufacturers assume that there's a difference of 5 between these two, and I think one of your case studies does that it asks for a hypothesized number, and then usually if it gives you a number for the difference, it's a one-sided test, because you're looking, is the difference less than that hypothesized difference or greater than that? So normally, if you're looking at a hypothesized difference that is 0, your null hypothesis and alternative hypothesis is a two-sided test. If you're looking at a hypothesized difference that isn't 0, it's almost always a one-sided test. So that's another little context clue as you read the problem. So here's the next thing, assume equal variances. Remember that we had 3 different options in chapter 10 of how we do a t-test. And so you could either assume equal variances, which is a pooled variance. You could not assume equal variances, which is the default position of the 2-sample t-test. That should be your default position as well, unless the question explicitly tells you that either it gives you the variances and says that they're the same, or it says to assume equal variances. Unless the problem specifically says that, leave that unchecked. The reason the default is that it's unchecked is because it's rare. That's not usually the case. And Minitab is made for professionals to use it in industry, not just students. So in the real world, most of the time, you can't assume equal variances. So if the question doesn't say it, leave that box unchecked. I think at least one time in your case study, I tell you to assume equal variances because I want you to check the box. And the answer will be somewhat different. Because remember, what does this calculate? It calculates the pooled variance. And that really long equation in chapter 10 for calculating the pooled variance, that equation is what Minitab does in the background. The other one, if you remember, calculated how many degrees of freedom should be chosen. If you can't assume equal variances, that you actually have to do a special calculation to calculate those degrees of freedom. It's, again, a really long equation and pretty involved. You'll never do that by hand, but that's what Minitab is doing in the background. That's what Minitab is doing in the background when we leave that box unchecked. So you can check it, you can uncheck it. Its default position is it's unchecked, and that's what we want. So we're going to hit OK. So we're looking to see, again, what's our question? Are the means the same? Meaning, can I save myself $250 by buying Club 2? So that's the question in mind. Are these performing the same, can I save myself $250? Okay, let's look at our data. Again, descriptive statistics gives me the confidence interval. This is what I would copy down onto my table, or again, I can click on the box and just copy and paste it. What is our t-value, our p-value, and our degrees of freedom? Our degrees of freedom are 21, so it calculated our degrees of freedom, which is useful in a t-test. And what's our p-value? 0.184. So our null hypothesis is that there is no difference. They are the same. What's our p-value tell us? Do we accept or reject the null hypothesis?
Reject.
Most accept.
Okay, so my p-value is greater than 0.05.
Yeah.
So I accept the null hypothesis. And the null hypothesis said that these were equal. So I'm accepting the null hypothesis that these are equal. What does that mean functionally? Can I save myself $250? Derek's nodding. Any thumbs up from anybody else? I got another nod from Julia. Those are the only two cameras I can see. So yeah, it means that yes, I can save myself $250. I can accept the null hypothesis that Club 1 performance is equal to Club 2 performance. There is no difference between these two clubs. And by the fact that there's no difference between these two clubs, accepting the null hypothesis just saved me $250, and I'm a happy person. All right, so we'll do one more test, and I'm going to copy and paste the data for you. Oh, that's chapter 9 data. Where's my chapter 10 data? Oh, I thought hold on one second, I need my chapter 10 data. Okay, so this was testing all right. I was starting to grab one and realize that that was the one that was in your homework. Okay, so test 1 and test 2 is what I have here. This is a before and after. So this is pre-test, post-test, which is like almost all of academic research on whether or not like new instructional technology is good, is we're gonna do a before and after test. Anytime you're comparing before and after, anytime you're comparing the same group of subjects, and one has done a treatment and one hasn't, you're using a paired t-test. So paired t-test, you have to have the same subjects looking at it before and after. So it's almost always done with people, not things, because if we're sampling things, you know, well, I guess you could do a before and after a treatment to a steel, and you could look at elasticity or do a strength or hardness test on a material after a treatment and say, does the performance differ after a treatment has been done? So before and after is always paired t-test. And a paired t-test is really interesting because a paired t-test, you can actually do two ways. You can do this by having a column that has the differences already calculated, which means you would do a one-sided t, or you can start with raw data and it will do all of the calculations for you. And so if you have, I think on your case study, you have, yeah, you have a before and after, and the difference is given to you. Are you able to see this case study too, minitab? Did it change screens for you? No? Let me share this one. Okay. Now do you see before, after difference? Okay. So for this question here, it's looking at the resting heart rate, and the question is, did their resting heart rate go down after starting a running program? So did this running program improve their health? And so they have before they started the running program, what was their resting heart rate, and then after. And a paired t-test means that when I look at one, the before data and the after data, that's the same person, right? All of these are paired with the same subject or the same sample. Now this column here has already calculated the difference between that, which means I could just look at the difference and do a one-sided t-test. But what I really want to do instead is I want to use minitab to tell me if there is a difference between these two, right? That's what I actually want to do. And so even though you're given a difference column, you don't need to use that data at all. So when you go to stat, and I'm not going to do the problem for you right now because you've got to do it, but when you go to basic statistics and you have paired t, you have, again, summarized data, differences, and then that would come from, you could get the data from this column. If I ran descriptive statistics on column C3, I could use the summarized data and just type it in. If I say each sample is in its own column, I'm only going to select before as sample 1 and after as sample 2. So that's how you need to set that up. So you can do the difference if you switch to summarized data, but I need to have already run the summarized data of column 3 before I open this window up. Because once I'm in this window, I'm stuck here. So I need to already have the summarized data in front of me. So if I was doing that, I would do stat, basic statistics, display descriptive statistics, and I only need column 3 displayed. So now I have my N, my mean, my standard error, my standard deviation. So now I could go to basic statistics, paired t-test, summarize data of the difference, and now in this window ahead of me, I already have all the information on column C3. So that's how I would do that. So if in a problem you were given this information as the differences for a before and after, you could just do that without having the raw data. That's where that's useful.
So that's going to yield the same results?
It will give you the same results. Because what does a paired t-test do? Well, if you remember, what the paired t-test does is it calculates the before and after difference. It calculates, if you remember the calculations in the textbook, the first thing you had to find was the mean of the difference, the standard deviation of the difference. Your N is just that same 20 samples because it's before and after. So your N is not a pooled N. You don't have a pooled variance. You're only looking at a single column. So if you already have the difference, really what you're doing is a one sample t-test. But if you're using raw data, it will actually do the calculations for you first, and that's all done in the background, and it'll spit out the same answer. But it will give you the same answer either way. So let's go back to our example, which we will run. So we're looking at test 1 and test 2, and we're going to do a paired t-test. And each sample is in its own column. So I have test 1, I select it, test 2, select it. My options, again, my question, my null hypothesis for a paired T, my default standing is that there is no difference. So most of the time in a paired t-test, I want to reject the null hypothesis, right? A lot of times I'm going to look for a low p-value and reject the null hypothesis because I want there to be a difference. I want there to be progress. But you know, the data is what the data is. If I have to accept the null hypothesis and say there is no difference, you know, this didn't help, nothing improved, like that is what it is. So maybe running doesn't help lower your resting heart rate. You know, that's good to know, because it's hard on the knees, and gosh, I don't like running. So, you know, I'm all for running not being good for you. But Julia's like rolling her eyes at me right now, which is kind of fun. Okay, so my null hypothesis that I'm keeping in mind is that there is no difference. I want there to be a difference. I want to reject the null. We're going to use that 95 confidence interval, and I'm going to run the test. So what do I have? It gives me the descriptive statistics of those two samples, because it had to calculate all of that before it could do the paired difference. This is what you would have had to calculate on your own to then use the formula in the textbook. So what's our p-value? Our p-value is 0.01. Is 0.01 less than 0.05? What does that mean?
Running is good for you.
Running is good for you, and darn it, we don't want it to be. Okay, so p-value less than alpha, reject the null hypothesis. The null hypothesis is that there was no difference, but there is a difference. Now, I might want to do this as a one-sided test where I would say running lowers your heart rate by at least 5 beats per minute. I could do that as well. What would I need to change? I'm going to change my window back to that question. Everybody see that question? Okay, so I'm going to go into this, and let's just walk through it. This is not what the actual question is, so we can go ahead and do it. Paired t-test. Each sample is in its own column. Before is sample 1, after is sample 2. I want to test, does running lower your heart rate by at least 5 beats per minute? What would I change? Is my hypothesized difference 0?
That'd be
5.
That'd be 5.
Yeah, okay.
So my hypothesized difference is that it is 5, but I want at least 5. So what do I want the sample mean? Do I want it greater than or less than?
Greater than.
Yeah, so that's how I would set that sample test up. So I'm now saying that I'm looking to test the hypothesis, not that these are the same, which we already said that they're not. Oh, I gave away the homework solution. They're not. Running is good for you. Okay, so if you do the standard t-test the way the assignment says, you're just looking at the hypothesized test of 0, and you're looking to say an alternative hypothesis that they does not equal 0. So it's just 0 does not equal 0 is what your homework or your case study tells you to do. But if I wanted to change this and say, does this lower my heart rate or by at least 5? So my hypothesized difference is great. My difference from this sample is greater than my hypothesized difference of 5. Let's see what happens here. So again, null hypothesis is that my mu is equal to 5. Alternative hypothesis is mu is greater than 5. What's my p-value? Is it less than 0.05? It's greater. If it's greater than, what am I accepting?
The null hypothesis.
My null hypothesis. Now in this case, I'm not really accepting that the null hypothesis is equal to 5. It's more about rejecting the alternative hypothesis. It's saying that I can't say that it lowers your heart rate by at least 5 beats per minute. That the difference between these two is not greater than 5. So it's not really saying that it equals 5 either. But what it's doing is it's rejecting that it's greater than 5. Does that make sense? So when you're setting up a problem that is one directional, either greater than or less than a hypothesized difference, when you're doing that, you're not really, you wouldn't look at this and say, oh, well then the mu equals 5. Well, it's the mu of the difference is equal to 5. That's not actually what you've confirmed. What you've confirmed on a two-sided test is that the mu is not greater than 5. Does that make sense? Okay, so I just wanted to be clear there because sometimes that can be confusing when you do these, is it greater than or less than, and you say like, oh, well, we accept the null hypothesis. When you accept the null hypothesis, you know, that says, well, the null hypothesis is that the difference is equal to 5. Well, that's not really what you're accepting here. Your statistical test was really about the alternative hypothesis. You were looking to say, do I accept or reject the alternative hypothesis? And by accepting the null hypothesis, I've rejected the alternative hypothesis. And that's just, it's just kind of verbiage with hypothesis testing, that sometimes what we're interested in, what we're really interested in, is actually the alternative hypothesis. But by accepting or rejecting the null hypothesis tells us what we're doing with the alternative. So sometimes we really are interested, does mu equal 80? You know, does it or does it not? Do these things perform the same? Yes or no? Is there a difference before and after? Yes or no? But sometimes we care more about directionality. And when we're doing a one-sided test, what we're really looking at is, are we accepting or rejecting the alternative hypothesis? And that part has been confusing in previous semesters. So I just really want to make sure that that kind of sinks in. That your statement for this, if this was when you get to that question that says, what does this mean? It does not mean the mu of the difference is equal to 5. It means that the mu of the difference is not greater than 5. Does that make sense? Okay, so we're at an hour. I booked an hour and a half. Mary, are you giving me a high five or are you raising your hand?
Oh, I'm sorry. I thought for a second that was clapping.
Oh, you're clapping?
I'm
Okay,
good.
sure.
Yeah.
I don't know all the little
I'm
emojis
good.
in this. Because I think there's one for raising your hand. Do you have one for raising your hand?
I think that was. I was just trying to mix it up.
Oh, okay.
Yeah.
I appreciate it. All right. So we're at an hour. Like I said, I will post this. So if you want to come back and look at it while you're working on case study 2 or anything in the future, and please always feel free to contact me. But there will be questions on your case study and then even on exam 3 where you're just going to have to kind of make some assumptions. And so the big things are, when in doubt, unless you are given specific information of a known standard deviation, assume it's a t-test. You probably will not see z-tests anymore. Just assume it's a t-test. Unless you are specifically told that you know that the variances are equal, or it says variance of sample 1 is 5, variance of sample 2 is 5, and you can just read that they're equal. Unless for sure you know that they are equal, do not check the box assumed equal variances. Leave that unchecked. When in doubt, do a two-sided test. Only do a one-sided test if you know for sure you're looking at one or the other, okay? When in doubt, do a two-sided test. And if you're given summarized data, you know, go ahead and just type it directly in. If you're given numbers to copy and paste from Word or Excel, copy and paste them, and just kind of make sure that you don't have data in that gray box, that the data starts at column 1, because otherwise I'll screw up your data. There will be some questions. I don't know if they're on case study 2, probably case study 3, certainly exam 3. I will change up the confidence level on you. I will change alpha. And so you can't just always leave it at 95. So make sure that you check that. And then make sure that you're really writing a complete sentence when it asks for a decision, like what does this mean? That you're not just saying accept or reject the null hypothesis, that you're adding that extra sentence that says, therefore, running is good for you, but not as good as we would like. You know, whatever it is, there should be a complete sentence that relates it back to the problem for full credit. All right. As always, if you have any questions, call, email, text. I'm trying to be accessible. And as long as we have this stay at home, I'm not doing anything. You can call on the weekends or whatever. Like I'll respond. Oh, and if Lily's still on, I don't know if Lily's still on, but yeah, I'm just grading all weekend. So I know you guys are behind in getting your grades back. So to answer Lily's question, but also for everyone else who may be wondering, I'll be getting all those grades up. Case studies certainly are going to be graded on correctness, not just attempts. And the homeworks that I'm writing as Word documents, they're certainly going to be graded on correctness for every example because they're pretty short. The Wiley homeworks from the previous chapters, I'll be looking at them, but since I'm kind of behind in grading, honestly, it's going to be graded on based on whether or not you did it or not. So if you did it, you'll get credit. I'm not going to select certain ones and grade them on correctness like I had been doing at the beginning of the semester. And I'll just speed up the process on my end. If you have specific questions on content, again, it's not a cumulative exam, so hopefully if you had questions, you got to me before exam 2 or during exam 2. But the exam 3 is not cumulative. It'll be all kind of 9, 10, 11, maybe 13 if we end up doing that. And I'll send out that Google survey. You don't have to say anything now within the group, but I'll send that Google survey out and everybody gets a vote. Solutions to the homework, Lily, is that what you're asking for? Or solutions to the exam? What are you? Yeah. Well, homework. Okay. Yeah, I can post homework solutions. If you did Wiley, just be careful that you don't look at just the number because the homework solutions, Wiley uses an algorithm to change the numbers. So the problem stays the same, like the wording stays the same and what it's asking for stays the same, but the numbers change with, you know, as each person logs on and does it, it'll change the number slightly. So the homework solutions are based on the questions from the book. If you did it in Wiley, the numbers may have changed. So you can look and check your process of how you attempted it, but the actual number may not match the number you submitted. Does that make sense? Okay. Also, I know I put on the syllabus that we'd be doing quizzes. It's just too much. It's too much for me. I don't know if it's too much for you, but hopefully you're not offended by not having quizzes. I think the case studies and the homework and the last exam are plenty of work for the next 2.5, 3 weeks for us, and then we can close the door on this crazy semester. So anyway, I will be posting homework solutions. I will be sending out a Google survey asking about whether or not you want to do chapter 13. And I will be posting the video from this so that you have that for review. And if you have specific questions as you start digging in, let me know. And if you continue to have problems with the VPN and minitab and the minitab file, Trevor was having issues. I don't know. Trevor, have you had a chance to see if it's worked for you?
No, I haven't tried again.
Okay. If that's still not working, please email me or text me or something. Let me know. But the one that I posted is from the previous semester while we were still on 2018. So it should be the right version, and you should be able to download it to a thumb drive or to your remote VPN desktop before you open it, and that should take care of the issue.
Okay.
All right, let me know if you're having any problems. It's Thursday. Have a great weekend, everybody, and I'm sure we'll be in touch next week.